The Milky Way is an immense cosmic structure, home to billions of stars and trillions of planets. These celestial bodies are surrounded by vast clouds of interstellar dust and streams of scorching hot gas, forming the breathtaking and mysterious entity we call a galaxy. Today, we invite you on an exhilarating journey through its wonders. Our adventure begins near the closest star system to our Sun, Alpha Centauri. Traveling at hundreds of times the speed of light, we will soar past some of the most remarkable stars in our cosmic neighborhood. Along the way, we'll briefly stop at an extraordinary planet, where a perpetually boiling ocean covers its entire surface, presenting a perilous yet fascinating spectacle. Venturing further, we will approach an unstable, pulsating giant star in its final millennia of existence before exploring the most extreme and inhospitable exoplanets. Then, we'll encounter the most enigmatic and formidable entities in the Milky Way black holes. Our journey continues as we pierce through the galaxy, racing from its luminous core, teeming with stars, to its distant outer edge, where the elusive dark matter remains hidden in mystery. Prepare for an unforgettable voyage as we embark on this cosmic odyssey. Alpha Centauri, the first step into deep space. For over a century, Earth has been transmitting structured radio signals into space. These signals have already reached dozens of stellar systems, including Arcturus, 37 light-years away, and Aldebaran, roughly 65 light-years from us. Additionally, they may have been detected on potentially habitable exoplanets, such as Ross 128b or Gliese 667cc. Yet the Alpha Centauri system remains our closest stellar neighbor, making it the prime candidate for humanity's first interstellar voyage. This multiple star system consists of three main components. The two larger stars, appearing as a single point of light to the naked eye, orbit a common center of mass in a slightly elongated path, taking approximately 80 years to complete one revolution. At their farthest, the two stars can be separated by a distance of up to 35 astronomical units. The Alpha Centauri system consists of three main stars, each with unique characteristics. The two larger stars orbit each other in an elongated path, with a minimum separation of 11.2 astronomical units. Their distance from the Sun is approximately 4.36 light-years, making them the closest stellar neighbors to our solar system. Alpha Centauri A, the brightest star in the system. The largest, most massive, and brightest member of the system is Alpha Centauri A. This main sequence star has a mass about 1.08 times that of the Sun and a radius 1.22 times larger. Despite having a surface temperature and spectral classification similar to the Sun, it emits 1.5 times more energy. Currently, no confirmed exoplanets orbit Alpha Centauri A. However, infrared observations in 2021 revealed evidence of a possible planet-like object nearby. Preliminary estimates suggest the celestial body could have a mass ranging from 9 to 35 Earth masses and a radius between 3.3 and 7 times that of Earth. Positioned 1.1 astronomical units from its parent star, it would take roughly a year to complete an orbit. Further observations, using the James Webb Telescope or ground-based observatories, are needed to confirm its existence. Alpha Centauri B, a cooler, more temperamental star. The second component, Alpha Centauri B, also belongs to the main sequence star category, but is slightly smaller. With a mass 10% less than the Sun's and a radius 86% of the Sun's size. Its surface temperature is 5,260 K, around 5,000 degrees Celsius, making it cooler than our Sun and giving it a distinctive orange hue. As a result, its luminosity is about half that of the Sun. Interestingly, Alpha Centauri B is known for its high X-ray emissions and frequent stellar flares and ejections, making it a more turbulent star than its counterpart. In 2012, astronomers from the Geneva Observatory suggested the existence of a planet orbiting it with a period of 12 days, slightly smaller than Earth. However, in 2015, a mathematical error was discovered in the data analysis, disproving the claim. To date, no confirmed exoplanets have been detected around this star. Proxima Centauri, the closest star to the Sun. The third component of the system, Proxima Centauri, is vastly different from the first two. It is a red dwarf, much smaller and dimmer, with a mass only 12% that of the Sun and a size 7 times smaller. Its surface temperature is a mere 3,000 K, and its luminosity is only 0.17% that of the Sun, making it incredibly faint. Despite its dim nature, Proxima Centauri is the closest star to the Sun, lying just 4.25 light-years away, hence its name, which means nearest in Latin. Moreover, it is slowly moving closer to us. In about 26,700 years, it will be just over 3 light-years away. Proxima Centauri is currently far from its two stellar companions, with a separation of 13,000 astronomical units, 0.21 light-years. However, in the next 300,000 years, this distance is expected to shrink significantly to just 4,100 astronomical units. Proxima Centauri and its planetary system. Proxima Centauri takes approximately 547,000 years to complete an orbit around the common mass center of the Alpha Centauri system. Unlike its two larger stellar neighbors, Proxima Centauri is home to at least 2 confirmed exoplanets and a possible third celestial body. Infrared studies also suggest the presence of a dust ring, along with numerous small objects, such as asteroids and comets. Proxima Centauri b, a potentially habitable world. Discovered in 2016 using the radial velocity method and confirmed in 2020 through spectrographic analysis with the Very Large Telescope VLT. Proxima Centauri b orbits its star at a distance of 0.05 astronomical units, completing a full orbit in just 11 Earth days. Estimates indicate that Proxima b is 10 to 20% more massive than Earth, with a radius approximately 1.3 times that of our planet. Mathematical models suggest that it receives 1.5 times less thermal energy from its star than Earth does from the Sun. With an average temperature of 234 K, minus 39 degrees Celsius, conditions could theoretically allow for liquid water in some regions. However, due to its close proximity to Proxima Centauri, the planet is likely tidally locked, meaning one side permanently faces the star while the other remains in darkness. A dense atmosphere could help regulate extreme temperature differences, but Proxima Centauri, like many red dwarfs, frequently ejects stellar matter and ionizing radiation flares, which may gradually strip away the planet's atmosphere. While a strong magnetic field could offer protection, the likelihood of Proxima b having one remains uncertain. Proxima Centauri c, a cold and distant super-Earth. In 2020, astronomers confirmed the existence of Proxima Centauri c, an exoplanet located 1.5 astronomical units from its star. It takes approximately 5 years to complete one orbit. Estimates suggest that its mass is between 6 and 8 times that of Earth, but its radius has not yet been determined. Depending on its size, Proxima c could either be classified as a mini-Neptune or a super-Earth. Because of its great distance from Proxima Centauri, its surface temperature is extremely low, around 39 K, minus 234 degrees Celsius. Observations suggest that this exoplanet might have a ring system nearly 5 times larger than Jupiter's. A possible third planet. Recent data from the Very Large Telescope VLT also hints at the existence of a remarkably small exoplanet orbiting just 0.029 astronomical units from Proxima Centauri. If confirmed, this planet would have a mass about 25% that of Earth and complete an orbit in just 5 Earth days. Its estimated surface temperature could be 360 K, 87 degrees Celsius. However, scientists remain uncertain whether this is a true planetary discovery or a measurement error, and further observations are required for confirmation. The challenge of interstellar travel. For over 100 years, Alpha Centauri has been exposed to Earth's radio signals. However, the vast 40 trillion kilometers of space between us present an enormous challenge for human exploration. While light itself takes just over 4 years to travel the distance, Reaching such speeds remains far beyond our current technological capabilities. Even today's most advanced spacecraft are nowhere near achieving such velocities, keeping interstellar travel within the realm of science fiction, for now. As we explore the wonders of Alpha Centauri and Proxima Centauri, we are reminded of the vastness of space and the mysteries it holds. From the scorching, radiation-battered Proxima b to the icy, distant Proxima c, these worlds challenge our understanding of habitability. The possibility of a third, yet-to-be-confirmed exoplanet adds to the intrigue, urging scientists to dig deeper into this cosmic neighborhood. Yet, despite our discoveries, the 40 trillion kilometers of space separating us from our closest stellar neighbor remain an enormous challenge. While radio signals have traveled there for over a century, human exploration of these distant worlds is still a dream that, with advancing technology, may one day become reality. Until then, we continue to watch, listen, and wonder about the secrets hidden within the stars. The universe is vast, and our journey has only just begun.